All right, and piecewise functions. Okay, so piecewise functions are just, they're easier dealt with by doing an example. So let's say example 1. Evaluate, I'm going to do a little shorthand here. Evaluate the piecewise function at the given values. Evaluate at the given values. And here, first I need to give you a piecewise function. So it starts out the same. You get a function and we label it f of x, or whatever you want to label it, g of x, h of x, so on. All right, here's where it differs. Usually we have a function and it just equals one thing. Now a function can equal two different things depending on the parameters that you put on it. And what I mean by parameters, x values. So you just start with a big squiggly bracket, and now I'm going to have two functions or three functions and so on, and I use those functions based on whatever x values that I'm given. So let me just show you. So let's say f of x is equal to x plus 2 if x is greater than or equal to 1. Instead of if, you might see the word for. It just depends, I guess. So what this is telling you is if your x value that you're wanting to find is greater than or equal to 1, then you use this function. All right? And we have f of x is equal to 4 if x is less than 1. So if the x value or the input you're looking for is less than 1, then you plug it into this function 4. All right, let's look at some examples. Part A, f of 0. All right, so you first need to identify what x value are you looking for. What x value am I looking for here? Well, it tells you this number here, 0. So I'm looking for which of these functions does x equals 0 fall under. So I need to look here and here. Now, is 0 greater than or equal to 1? No. Is 0 less than 1? Yes, it is. So that means I use this function. So I'll plug 0 in here for all x values. So there's none, so the answer is just 4. All right. What about f of 5? So you have to ask yourself when you're working these, what is my x value that I'm looking for? My x value is 5. Then you need to see where that falls under. Is it greater than or equal to 1? Or is it less than 1? So it's greater than or equal to 1, so it falls under this function. So you plug 5 in here everywhere there's an x. So 5 plus 2. 5 plus 2 is equal to 7. All right. C. What about f of 1? At any time, pause the video and try a couple of these yourself. F of 1 means my x value is 1, and I need to come over here and see which parameter it falls under. Is it greater than or equal to 1? Yes. So, and just to check, make sure we're not going and saying, is it less than 1? No. So it falls under this one, so I'll plug 1 in here everywhere there's an x. So I get 1 plus 2, which is 3. All right, and so it doesn't matter how big or small the number is. If I have f of 100, you still just see which one it falls under. 100 is greater than or equal to 1, so I use x plus 2. X plus 2 means 100 plus 2, which is 102. All right. Now we want to look at graphing something like this. And it seems a little daunting at first, but all you're doing is you're graphing, you're graphing two functions. You're graphing this, and then you're gonna graph this. Okay, so what I'm gonna do, and just so I get everything out there now, and I'll repeat it again, I'm sure. I'm gonna graph this entire function. And then I'm gonna look at where it's valid. It's telling me that it only wants numbers of x greater than or equal to 1. All right, so then I'm gonna erase the graph anywhere it's not greater than or equal to 1. And then I'm gonna do the same thing here. Let me show you. Here's my x-axis and y-axis. All right, and so there are a couple ways you can go about graphing this. Obviously, the calculator is easiest. You can find the x and y intercepts and connect the dots. I encourage you to do that, so that way you have practice finding x and y intercepts, because that's going to be important. So I'm just going to go ahead and graph this for you. If I were to let y equal 0, then I'd get an x-intercept of, so this would be -2, 0. And then if I let x equal 0, I get y is equal to 2. So I get those 2 points there, and then I just connect the dots. And when you're doing this at home, draw lightly. When you do this part, draw lightly, okay? Because I want to draw the whole graph right now, and now I want to limit it to this x greater than or equal to 1. So come on your graph and draw 1. Here is 1. That's important. So I only want the x values of that's greater than or equal to 1. So here's my 1, and I only want the values greater than or equal to 1. So I want all of these values here, this direction. These I don't care about for x plus 2. So what I'm going to do is I'm going to come up here and I'm going to draw a solid dot right where the graph and x plus 1 meet. And then I'm just going to erase everything behind it. Again, I only care about x greater than or equal to 1. So that gives me all the values of x greater than or equal to 1. And notice I use the solid dot because it's greater than or equal. The equal portion makes it a solid dot. Okay? So that's half of it. Now we need a graph f of x equals 4 for all the x's less than 1. But what I'm going to do is I'm just going to draw the entire graph of f of x equals 4. And what that looks like is, I come up here to 4. And it's just a vertical line. I forgot to label. Make sure to label. That's good practice. This is f of x equals x plus 2. That way I don't get confused later. And then it keeps going this direction like that. So this is f of x equals 4. Now I want to limit it to x less than 1. So here's my 1, and I want all the x's less than that. So I'm going this direction. So I don't care about anything this direction for x equals 4. And since it's a less than, I put an open circle right there. And that now is my graph of this piecewise function. So just view it as you're putting 2 graphs on here, and once you put one graph at a time, and then erase the x values that you don't need, and then put the other function and erase the x values that you don't need.